This is a video summary of our paper at IEEE SLT 2022. I'm Guanting Lin, and I welcome your questions and comments. Our title is as shown on the utility of self-supervised model for prosody-related tasks. The paper is about how surprisingly useful for prosody-related tasks are models pre-trained to prosody-unrelated objectives. Okay, so why prosody? Spoken language involves words, which are the focus of most research, but also the prosody. While under study, prosody is important for real-time human communication. In dialogue, for example, prosody is largely how people convey their attitude, positive or negative, etc., or stance, intent, take turns, and so on. Now there has been some works on modeling prosody, but mostly on pure linguistics. That is to say, aspects of speaker identity, gender, age, etc., or current states, healthy, sick, angry. The other aspect is phonological, like Mandarin tones and word stresses in English. Our focus instead is on the pragmatic and interactional aspect of prosody. This has been less studied, and to date, the state-of-the-art is using handcraft features and fully supervised training. Can we do better? Specifically, can Pretrained models help? We know that the self-supervised Pretrained model do very well for many tasks, like in the SUPERB benchmark. But the value for pragmatics-related prosody has not previously been studied. That is the aim of this paper. We here propose a SUPERB-prosody framework. Following the SUPERB benchmark, we extract the hidden representations from a frozen SSL model, and lightweight linear models are used for each downstream task. There are two kinds of tasks. The first is prosody-intensive tasks, and the second is prosody pseudo tasks. So the first task is sarcasm detection. The mismatch between the lexical content and the prosody message is frequently the major marker of sarcasm. So our goal is to detect whether this utterance contains sarcasm or not. The second one is persuasiveness prediction. It aims to detect whether a presentation is likely to be convincing to others. Correlates include how pleasant the speaker's voice is in their perceived confidence and dominance. And the third one is sentiment analysis. It aims to detect the degree of positive or negative feeling in an utterance. Sentiment analysis is different from emotion recognition, that sentiment is less visceral than emotion. Furthermore, we construct prosody pseudo tasks. The first one is prosody reconstruction. It wants to test whether self-supervised model embeds specific prosody features like pitch and energy in their hidden representations. And the second one is future value prediction. It wants to test whether the output from self-supervised models can predict future prosody information. Here is a comparison of different experimental setup. So here our SUPERB-prosody framework uses the Pretrained model for feature extraction and only do the text-specific training by linear layer. And please note that the text baseline here indicates how well this text can reach only using lexical content information with strong NLP Pretrained model. Here is the result of our experiments. So here, different colors means different self-supervised model and the SOTA FBank text baseline. In the figure, we can see that self-supervised model perform well on prosody-intensive tasks, mostly better than FBank features. And some self-supervised models show superior performance than text baseline, even reaching the state-of-the-art performance. In conclusions, Pretrained self-supervised models work very well for prosodically conveyed pragmatic functions, outperforming handcrafted prosody features and outperforming powerful recurrent models on low-level features. Thus, they should almost always be used. In addition, they are good at extracting prosodic information in pseudo tasks. For more results, please see the paper or meet us at poster session. We thank the support from IEEE Workshop and Taiwan Web Service. Thank you very much for your listening.